Docker is a powerful tool that allows developers to set up environments quickly, configure complex systems and servers easily, and deploy software reliably. Yet, it's also a source of great confusion. In this video, we're going to get a look at what Docker is, how it works, and how to use it in our development tasks. Once you get used to how Docker works, it will become a valuable part of your development process. Now, if this is the first video you've watched of mine, my name is Tim Corey, and it's my goal to make learning C# and the related technologies easier. I provide videos twice a week here on YouTube to help you grow as a developer. I also have a full set of training courses on IAmTimCorey.com. I encourage you to check out all the resources that I have to offer. In this video, as with most of my videos, I'm going to create some source code. If you'd like a copy of my source code, use the link in the description. There's also links down there to the other websites I'm going to visit in this video. Now, let's get started by going to the Docker website. If you don't have Docker installed, go to docker.com. Under products, you can go to Docker Desktop. Now, if you are on Windows, you can download it for Windows. If you're on Mac, you can download it for Mac. And then here's the View Linux engine to figure out how to install it for your particular distribution of Linux. Now, there is a caveat here. There's a disclaimer. If you're on Windows and you're on Windows 10 Home, you won't be able to install the Docker Desktop. Now, don't worry. You can't install it this way. There's a way to install Docker for Windows 10 Home, just not this way. In fact, I'll include this link down below, but if you go to the docs for Docker, there is Install Docker Desktop on Windows Home, and it walks you through the process of using the Windows subsystem for Linux. Now, there is still some limitations. So I haven't mentioned Windows 7, Windows 8, Windows 8.1, or Windows XP for that matter. Older versions of the operating systems probably aren't going to be supported. Now, if you have a Windows 7 machine, you can look for the Docker Toolkit, and that may still work, but I have no guarantee that it will continue to work. I'm not sure where it's at. Windows 7, Windows 8, they aren't supported anymore, both by Microsoft and also by the Docker Foundation. So just note that you're going to have Windows 10 for modern development. So Windows 10, at least Home, and using these instructions, or for Pro, Enterprise, or Education editions, you can just go to the Docker and get the Docker Desktop. Install that, and once you do, it will run in your system tray. So I'm going to quickly bring up my version of it here, and I'll bring up the settings for it. So these are the settings for it. Just so you can see what I have set up, it's pretty simple. I'm using the Windows subsystem for Linux, which is a little bit better performance than the Hyper-V backend. Windows subsystem for Linux is a newer thing with Windows 10, but it's some really powerful stuff you can do. Basically, it runs Linux for you if you want. Now, I have Docker Desktop start when I log in. That's kind of important. And I don't have it show me weekly tips or start the dashboard on startup. As for other things here, I don't have any in resources. I do have it enabled for my default Windows subsystem for Linux distribution. You can have it for additional subsystems that you want, or additional distros, but I just have it for my base distro. If you don't know what that means, don't worry, okay? Leave it alone, it's just fine. Docker engine, don't touch this. Experimental feature, Kubernetes. Kubernetes, if you're just learning about Docker, do not enable Kubernetes, because Docker can be somewhat confusing. You need to get used to how Docker works, understand what it does, and use it for a while before you even think about Kubernetes. This is like, day one of primary school is Docker, and then this is a master's degree higher education or a doctorate, okay? That's the difficulty level difference here. So start off where you're at, which is probably getting introduced to Docker or just getting started with Docker or in the early stages of using Docker. Use that first before you try and dive right into Kubernetes. If you start by trying to get into Kubernetes, you will get frustrated, you'll get overwhelmed. There's a lot you need to know. Start with Docker and then move from there, okay? So I'm just warning you here, don't check this box unless you really know what you're doing. Okay, now, the other thing is I have set up my Docker to work with Linux, even though I'm on Windows. And that's a fairly common thing to do. In fact, I would encourage you to set up your Docker to work with Linux. If you right-click on the Docker whale that's in your system tray, I can't show you because my system tray is on the other screen, but if you right-click on it, it will say something like change to or switch to Windows containers or switch to Linux containers. If it says switch to Windows containers, you're running on Linux. If it says switch to Linux containers, then you're running on Windows. So I'd switch to the Linux containers. There's a lot more of them and they are a lot lighter. The only time you need to switch to a Windows container is if there was something that was specifically for Windows, which if you're a C# developer, then with .NET Core, you're probably okay sticking with Linux. I deploy all of my .NET Core web applications to Docker in Docker Linux. Okay, so I don't mess with the Windows version very often. Okay, I'll have links to this and also to this down in the description. Now, let's talk a bit about what Docker is. Now, to do that right, I'm going to draw this out just to try and make sense of Docker. And we're going to go to the high level here. We're not going to go into the weeds and go real deep. I just want you to get used to the basics here. So let's talk about what is Docker compared to, say, a virtual machine. So you may have heard about a virtual machine, which is a full installation of something. So you have, let's just pretend this is our virtual machine. And in that virtual machine, we have our installation of Linux or Windows. And that's everything below here. That's our OS. And then we have on top of that, we install our applications. Okay? So those are applications we install on top of our operating system. And this whole thing here is a virtual machine. Okay? The problem is that that's very, very large. We have to maintain the whole thing. And so what Docker's a little bit different than that, because what it says is let's reuse as much as possible, because a virtual machine runs on something. In fact, it runs on another machine that has an OS and it has applications, one of which is your virtual machine host, which then runs your virtual machine. So you've duplicated your operating system. So right here, you got duplication. And Docker says we can do better than that. So what we're going to do for Docker, pardon my handwriting there, but for Docker, what we're going to do is we've got the host operating system, right? So that's our host. That doesn't change. We have the OS, and we have applications that are installed on it. But for Docker, we're not going to install a whole new operating system. What we're going to do is we're going to expand this box out. It's not as big as a virtual machine, but I'm going to expand it out a little bit, like so. And we're going to say, well, the operating system, we use this little layer here, because what we'll do is we'll actually pull bits from the operating system that we're running on. So there is an OS layer, but it's tiny. And not only that, we're going to start with the bare operating system, meaning an operating system typically has a whole bunch of stuff installed. For example, if you install Windows, one of the things you get usually is some kind of games. You get Minesweeper, you get maybe Solitaire. You also get a bunch of utilities and other things. With Docker, what they do is they say, well, we're going to pull a lot of stuff from the main OS. But then what we do install here, let's get a big highlighter here. We do install right here, it's going to be as tiny as possible, just the bare minimum. And then what we'll do is we're going to install on top of that a little layer. And that little layer is whatever else you want to put on there. And we'll kind of stack these layers as tiny as possible, adding just the things you need. So for instance, we're going to look at, in this video, we're going to look at a web server that runs on Linux. So it's going to start off with a really little Linux distribution, okay? And then on top of that, it's got this really tiny little distribution of a web server. And then on top of that, you can barely see it, we're going to put our files. And that's going to be our, what's called an image, okay? This right here is an image. That right there is an image. Now I've blown that big one up just so you can kind of see in more detail. It represents a very tiny little thing. So what Docker is a series of layers. And the first layer starts off with the host operating system. Now, I am running Linux containers. And you may say, but Tim, you're running on Windows. How does that work? Well, it's running on top of the Windows subsystem for Linux. So technically, my computer is running Linux on it as well. And that's, again, baked into the latest version of Windows 10. Before this, we would use Hyper-V, and we'd install a version of Linux on our machine as a virtual machine. So this way is more efficient, the Windows subsystem for Linux. But either way, I'm actually running Linux on my machine, a very small version of it. So that's where the operating system bits come from. But then what I'll do is I will run a web server of Linux, which is going to take a small extra chunk for the operating system itself, and it's going to have a layer for the web server itself. And then what I'll do is on top of that, I'll put my own files. And that's where we're going to stack this up. Now, what's the benefit of all this stacking? Well, first of all, we aren't making a whole operating system like over here. We're just grabbing pieces of it, okay? So this right here becomes smaller. Now, on top of that, we're not capturing all of these extra things that come with the operating system. We're only pulling the things that we need. So instead of it being massive, we've got a small little layer. Now, the next thing is that each of these layers right here is independent. So think of this like, I don't know, Lego bricks, where you have one brick, and then on top of that, another brick, and then on top of that, another brick, right? Well, what if we want to build another a Docker container using these two bricks? Okay, not a problem. What we do, let's change pen colors here, is we'd take these two bricks that are the same and bring them over here and use the same ones, and then we just build on top of that the additional things we need. So these right here would be from over here. So we don't have to recreate or recopy those pieces. We can just use them once or download them once and use them for multiple Docker containers. Okay, so that might be a little abstract. It might be a little confusing, but I'm going to show you how all this works. We can come back to this if you want, but we're going to see how this works in the real world. You'll see this layering technique. And this layering technique is really powerful in Docker because it makes it much more efficient on our computers. Instead of this whole virtual machine over here, what we have instead is we have a bunch of layers that are much thinner, that get downloaded once, they get reused, and then what'll happen is that our applications themselves are just what gets added on top. Now, in our case for our web server, let's just say that the web server is this right here, okay? Now, the actual web server is 55 megabytes. All right? That's not much for the whole Docker container. So, we're going to have a 55 megabyte container because our files are going to be really tiny. Okay? But what if we had two different containers that both use that web server? You'd say, well, that's 110, right? No, because we're using this technique of copying and reusing. So it's not that it's 110. It's actually just the 55 plus our differences. So our difference can be less than a megabyte. So each of we can have 10 different containers running 10 different instances of our Linux server, web server, and yet our total size on disk would be less than 60 megabytes. And the difference is that 5 megabytes would be for all of our files across all our different projects. So that is huge compared to a virtual machine, which can be 200, 300 gigabytes. Or, if you're really tiny and trying to get it shrunk down, okay, maybe even if it's 55 megabytes for a virtual machine, which it won't be, but let's just say it was. If you have 10 of those, it's 550 megabytes. Reality is you're probably more towards a gigabyte per, which means 10 gigabytes of storage versus 60 megabytes. See the difference there? Transferring over the wire, that's also a big deal. Okay, that's kind of the conceptual version of it. Let's see it in action. So let's go to Visual Studio Code. Now, I've installed Visual Studio Code because it's a really quick and easy code editor. I have installed the Docker tools, which I zoomed in here. So let's remove some of these extras. There we go. There's the Docker tools there. If you want that, you go to extensions and search for Docker. And it's install the Docker tools. And this will give you some IntelliSense highlighting on the Docker file, which we're going to use, and also allow you to see some images and other things. So we'll get into what images are, what containers are, and so on in a bit. But for now, just note that I do have that installed. Let's start by opening up a folder. I'm going to open up my Docker folder in my demos. I'll give you the source code so you have it. But my Docker folder is empty right now. So there's nothing in there. It's just a starting point. So what we're going to do is create a folder. We'll call it HTML. And then inside this folder, we'll create a new file called index.html. Okay. Now, if you're not familiar with HTML files, they are, if I can spell, they're pretty simple. And I'm going to create this one as a very simple HTML file. I'll put the head in there just to have it, but we're not going to do much with it. And then in here, I'll say h1, and I'll say hello Docker. And we'll create a paragraph here and say this is our Docker website. All right, that's it. If we were to run this, what'll happen is, I had a problem with my live server, but I have live server extension installed, which if you go to extensions, go to live server. This is a nice little extension when it doesn't crash. But what it does is it allows me to push this go live button here, which will start my website and go right to my file. So hello Docker, this is our Docker website. All right. So that's our basic website. Nothing to be too excited over, but just note that we have something working. Okay, so I have my website, but now I want to figure out how to create this in a Docker container. I want to create a Docker container that will allow me to build this into what's called an image. Now, there is some key terminology here. An image is that an additional layer, essentially. So we have all the different layers where we have the base operating system, and then add on top of that the web server. On top of that, our files. That our files layer will create what's called an image. And each level below is also an image. An image is read only. And so what this does is it creates a point in time for our application that says, okay, this is right now. This is what we're going to build in our current version. And then what you do is if you want to run that image, you turn it into what's called a container. And a container runs the image and may make some changes, may create data or whatever. But if we ever have a problem with our running container, we can destroy it and create a new container based upon the image and start right back up, because our image is read-only, which means it should be the same and work the same today, tomorrow, and a year from now. So we're going to create first our Docker image, all right? But how do we do that? Well, we're going to go back to the root here, and we're going to create a new file, which I'll put this file right under the root. All right. It wants to be put under HTML. I'm going to move it up once we create it. Docker file. All right. And let's move that. Come on. Well, here's what I'll do. I will save this, Control S to save it, close it out. And then what I'm going to do is go over to my File Explorer, and I'm just going to move it for me. I don't want to mess around with VS Code. I'll make it work. There we go. So in my Docker file, this is going to allow me to create a setup. It's going to say, okay, here's the things that I want you to do. And the first thing I need to do is I need to get a base image to work from, something to build on top of. Okay, remember, again, Docker is these layers. So I need to build on top of an existing layer. So what layer do I use? Well, I'm going to use a small little web server. To do that, I'm going to go back to Docker Hub. So hub.docker.com. This is part of the Docker website. And the hub will allow me to search for or explore the Docker images on there. These are the base images that you then add on top of potentially, or just use them as they are. So we see here Postgres, Ubuntu, Alpine, Redis, Node, MySQL, Mongo. Notice the 10 million plus downloads for all of these. Python. You can even run Docker inside of Docker for some kind of inception level setup. But what we're going to do is we're going to search for a web server called HTTPD. This is an Apache HTTP web server. If we click it, this is going to tell us all about the web server, including if we look here, here's how to put that into your Docker file project. And let's zoom in there a little bit there. So we're going to start by saying from, and then say the web server is HTTPD. That's the base image. Then we give this colon, and then they have 2.4 here. We're not going to use 2.4. But what this is called a tag. And there's different tags. You can see if we go back to the top here, under tags, there's a whole list of tags. And you may say, well, what tag do I use? How do I know which one? Well, in general, you would use the latest tag. And that latest tag will give you the latest and greatest stuff. It's the last or latest image. This was pushed 9 days ago. But for us, because I want certain things in my image, I actually want the Alpine tag. The reason I know this is because if we go back to the description and we look down here, it's going to tell us that the different variants. So the Alpine Linux project available in the Alpine official image is much smaller than most distribution bases and thus leads to much slimmer images in general. So this is a really tiny little web server. Now there's some compromises with being that tiny. They've taken a bunch of things out. This is really stripped down to the bare minimum that we need. The fact that it's based upon a 5 megabyte operating system is insanely small. And then we're going to build on top of that. Like I said, it's about 55 megabytes total. So what we're going to do is we're going to say first from. And I don't think I mentioned here yet, the Docker file has no extension. It's not .dockerfile. It's not dockerfile dot something. It's just Dockerfile. All right. So make sure you note that. So from HTTPD. Notice I have IntelliSense here. That comes from that Docker extension. That's kind of nice. I can say colon, and I'll say Alpine. So this says that our base image for this image we're going to create is the HTTP Alpine version. Next up, we're going to do something. In our case, we're going to copy files. So I'm going to say copy, and my source is going to be ./HTML/. So everything in the HTML file. That's why I wanted to have my HTML document in that subfolder. That way I can copy the entire folder and everything inside of it over to my image. I put a space, and then I put my location on disk, /usr/local/apache2/htdocs/. Now, how did I know that path? Well, again, we come back to our documentation. We come back up near the top here, and they're going to tell us how to do that copy. It's right here. So if we look at this, it says copy from, wherever you're copying from, and then to /usr/local/apache2/htdocs. So what's happening here is it's going to take the files from this location and put them in this location. So in our case, it's taking the files from the HTML folder and everything inside, and it's putting them in the htdocs location. That happens to be the place that the web server is looking for to run your web application. And that's it. We saved the file. We've created now our Docker file. The Docker file is a script that tells you step by step what to do to create our image. Now, typically Docker files are much larger than this. They'll have multiple steps with multiple different wording here and different options where they're doing some configuration, maybe changing a login name and password, changing ports, mapping ports, and a whole bunch of other things you can do. There's a lot you could do here. Now, I'm not going to cover that all in this intro video. This is just to get you started and get you seeing what Docker can do. But if you did want to go deeper, just so you know, I do have a Getting Started Docker course, which we look down here. The introduction, by the way, is free. So you get to see the what is Docker, the structure of Docker, the benefits, the key terms, and so on. Then we cover the container basics, and then options. There's the from, copy, working directory, expose, run, volume, entry points, and more. Volume, really important. That allows you to map files on your computer and leave them on your computer, which allows you to have your image save changes that are persistent even after you shut the container down or start a new one. We also go into building with .NET, working the command line, and manually creating a Docker file for a .NET project. Just so you know that that's there. That's not what we're covering today. I just want to make sure you had more resources in case you needed them. But for this, what we're going to do is just these 2 lines. So let's open up our terminal. I'm using PowerShell here. Let's clear the screen. And if you have Docker installed, you can say Docker, and it will give you a whole bunch of different commands you can do. There's a lot here. But let's start off with doing Docker images. This gives you a list of images. Again, images are those read-only builds, okay? So the first thing we're going to do is we're going to create our own image. So let's say Docker build. Now we give it a name, so -t, hello dash, let's do hello dash Docker, and then :1.0.0. So this will be the name of our image, and this is going to be the tag. Now, normally you'd create one tag called latest, but what we can do is we can version these. So the next version will be 1.0.1, and then we can add an additional tag to it that says latest, and move that latest up every time we create a new version. So we're not gonna get into that in this. Again, that's covered in the Getting Started Docker course, but just know you can tag it multiple different ways, which is what is very common. But let's start with our 1.0.0. Now, I'm gonna show you something that I think I miss almost every time I start creating a Docker image. This is one thing that it trips me up every time. And that is after you've said Docker build and -t to give a name and a tag, then you hit space and you hit the dot or the period. It's so little, it's so easy to miss. Don't forget to do that. If you forget to do that, you'll have an error. In fact, I'll show you what that looks like. It says Docker build requires exactly 1 argument. So if you see this error, before you write in the comments and then have everybody else go, did you listen to Tim? Just space dot, okay? It's really easy to miss. I do it all the time, even when I have notes, because I miss the fact there's that little space there, space and dot. So that space and a dot, you hit enter, and now what's happening is it's building our image. So we have now built our image. Let's clear the screen. Docker images. There's our image. So we've created now our hello Docker image right there. The tag says 1.0.0. This is the image ID. This will be important for referencing this image later. Now it's created 11 seconds ago, which makes sense. We just created it recently. And the size is 55.5 megabytes. And again, you may say, man, for one HTML file is that big? But let's look at the Docker image history for this image. I'm gonna use the ID for this. So 83B. Now you may say, I don't want to type that whole thing out. Don't. All you need to type out is enough to be unique. So it looks through the images, it finds one and only one match. I just do the first 3 letters or letters and number combination. That's usually enough to make sure it's unique. Hit enter. Now this is the, let's expand this a little bit. This is the complete setup of our image. Now remember, it's based upon layers. So let's start off at the very bottom here. 5.5 megabytes. This right here is the operating system. That's the Linux operating system. Now, they ran some commands, notice 3 weeks ago, they ran some commands on top of that where they ran the shell and then they ran this command, the setx command or set-x, and that added an extra 4.68 kilobytes. Then made some environmental variable changes and so on. And then up here, they added an additional 49.9 megabytes. I believe that was when they brought down the actual web server itself. So there's Linux, there's the web server, a little bit extra configuration here. And then notice that this line right here says about a minute ago, copy HTML to the htdocs folder. That's what we did. Notice that the difference is 183 bytes. That's it. So because it's that small, the actual size of the virtual size of our container is 183 bytes, because based upon a different container that has the 55.5 megabytes. So when it comes time for storing this image, it's really tiny. All right, so just note that we're not storing all 55.5 megabytes to an extent, okay? When you download this to your computer, you are storing 55.5 megabytes. But when you create a second web server, you're not gonna duplicate that, okay? You have to have the base image on your machine in order to run this. But when you're pushing this up to the cloud, you're not storing 55.5 megabytes, almost certainly. You're storing just this 183 bytes. The server has to have it once, but not once for every instance, okay? So yes, it gets a little confusing to figure out the sizing of it, but for the most part, you're really talking about this right here. Just the changes that you did and the size that they incur. Okay, so that's that hierarchy I wanted to show you. Let's talk now about actually running this. Because when you run an image, we create what's called a container. And a container takes the image and runs it, but it just runs on top of it. And then if we destroy that container and start over, it's gonna start over from the image, which again is read only. So if you save files to your operating system in the container, that'll work because the container is read-write. You can write to it. But if you then try to destroy that container and recreate it from the image, those changes will be gone because they do not persist in the container. If the container gets destroyed, they're gone. Now, if you can keep the container running, then yes, they're persistent as long as the container keeps running. But just note that's not typically what we plan for. We plan for the image being refreshed or reloaded for our containers. So I know it's abstract. Let's talk about the actual practicality of it. So let's run our image. Docker run -d. Now, I do this a lot, -d. -d stands for disconnect. And what that means is that even after we close down this terminal, it will continue to run. That means it will run even if I shut down Visual Studio Code. It's always going to be running in the background until I reboot, okay? So I like to do -d. I'm going to take it off for this first run because I want you to see what happens. If you take off -d, it will stay open and keep a connection open to that container, and we'll see whenever a command comes through. So we'll leave it off for now, but just note normally I add the -d to run disconnected. --name. Let's give us a container, so we'll call it first container. And then this is a web server. So I have to somehow talk to it. I have to communicate in order to see my website. So I have to say -p. And what this will do is it will allow me to map a port from my container to my machine. We start with my machine side. What port do you want it to be on your machine? So on my machine, I want it to be port 8080 because that one's currently free. Now, if it's not free, choose a different one. It can be anything you want. 1, 2, 3, 4, cool. That'll probably work, okay? Just make sure that you're not already using that port for something else. Now, push :, and then you give it the port number of your Docker container. What's gonna be inside that image? Well, inside the image it's going, or inside the container, it's going to be port 80. So the left side is my machine. The right side is the image. So it's going to take all the traffic that we send over port 8080. We say localhost 8080, okay, for my machine / local 8080, and send that traffic into the container on port 80. Okay? And we're going to say we need to tell it which image to use. Well, hello Docker version 1.0.0. So we're going to run that image. I hit enter, and it says okay, and we're actually running. Now, it's saying, okay, can't reliably determine the server's fully qualified domain name. Don't worry about those messages. That's just the web server griping about the fact that we haven't configured it for production yet. Not a big deal. So we've got this running. Now let's open up our website and go to localhost 8080. Got it. Localhost 8080, not HTTPS, just HTTP. It says hello Docker. So we're running. We're running on our web server inside of our container. Now let's look at that and notice right here we have a colon, a get on. All right, we got a 200 response, which means success, and we sent back, I think, 183 bytes. We also have a 404 on the favicon, so we don't have that file on our HTML file. So we could specify that, and then we'd have one, but we're not going to. So Control-C here to stop that. I'll clear the screen. And now if I do Docker, first of all, Docker images, we still have just that one image. That's the image we created, okay? We also have Docker PS, I'm gonna do -A. So Docker PS is gonna show me all of my containers. Why is it not Docker containers? I don't know, but it's Docker PS, and then I say -A. And what -A means is all. That shows me not just the running containers. So Docker PS will show me just the running containers. Docker PS-A will show me the running containers and the turned off containers. In this case, I've got a container that is running. So it's been up for the past 2 minutes. And notice it says port 8080 goes to port 80 in the container. It's based upon the image, hello Docker 1.0.0. And this is the container ID. Notice it wraps a little bit. That's just because of the size of the font. If it was a little bit smaller, in fact, let's do that. There we go. Now you'll see that container ID is actually over the ID. So if it wraps like that, just if you can zoom out, that'd be great. But otherwise, you have to look at the column headers and make sure they line up. So let's zoom back in a little bit. Notice how it's a little bit off, that's all. It threw me for a loop the first time I looked at it because of the fact that things didn't quite line up right. But this is our container ID. This will use the first 3 letters, or letters and numbers, to reference it. So for example, I can say Docker stop 3C7. Okay, now I can say Docker PS-A, and notice status is now exited 4 seconds ago, meaning it shut down. If we go back to the website, and if we try to run this again, it will time out trying to connect to it. Can't be reached because the server is down. If I want to start it back up, I could say Docker start 3C7. And we'll start that container again. Now, if I hit refresh, we're good to go. Our web server is back up and running. So in my case, I'm going to say Docker stop 3C7, and then one more command once it stops, It takes a second sometimes to stop it. Well, the one more command is going to be docker rmi. So, I'm sorry, rm. Docker rm 3c7. If I do it in the right order. Docker rm is going to remove, that's what rm stands for, is remove, the container. So now if I say docker ps-a, which is show me all the containers, I have no containers. So it's gone, it's destroyed. Okay, Docker images, I still have my image. Now let's just make some changes to our files. So we have our index.html. Let's go in here and create a new file called about. Okay, and we're gonna go to our index page and just copy this whole thing, paste in here, and here we're gonna say about us. My name is Tim Corey, and I created this site. I'm not sure I want to claim that, but there we go. So let's, on my index page, we'll create another paragraph tag here. We'll create an anchor tag with an href that's equal to about.html. And we'll say about us. Real simple. So to have, let's go live here to see it. This is our Docker website. Now about us. About us, my name is Tim Corey, I created this site. Okay, that's our website. So, and notice if we refresh this, it's not there. It's gonna time out. So how do we now put this into our image? Well, we don't in some ways. If we, let's stop this. If you go back to our terminal and look at our image, this is version 1.0.0. That is going to be fixed, set in stone, never changing. That's a read-only image. It's never going to change. We don't want it to change. Instead, what we want to do is create a new image that is going to replace this. So we give it the docker build command. Docker build -t to give it a name, or name and tag, technically a tag. hello-docker : 1.0.1 space, don't forget the dot. Okay, that builds a new image. Now Docker images gives us two images. We have our Docker image 1.0.0 and our Docker 1.0.1. So now we can do Docker run. I'm gonna do disconnected this time. -- name is going to be second container. And -p for port. Same port, we haven't kept the original one around. And in fact, you know what? Let's change this. Let's keep this port the same, or I'll build the old version again. So we'll create this as a first container again. Oops. I can't do it that way. Forgot where I'm in a terminal. First container. And we're going to say hello Docker 1.0.0. Okay, that's the same command we ran before, except it's disconnected. And if we go back now to our web server and run this, we get our hello Docker, the old version. I'm going to create the same command again. Well, I'm going to change it to 1.0.1, and I'll change the port to 8081. We'll call a second container. And both will run at the same time. So now let's go back to our web server. If we refresh this, it's still the old version, but if I go to localhost 8081, there is our hello Docker. This is our Docker website. About us. About us. There's the information about us. So we now have two different versions running on our machine at the same time because we have two different web servers running. Now, why is that important? Well, what if you had your development server, maybe this one right here, and you had your staging server, the one's closer to production, or the production duplicate. Okay, you could have both and you can compare them side by side or run them both on your machine if you wanted to. You could test against both. So, and maybe that's not something you do every day, but it's something you could have running if you wanted to. Now, let's clear screen, Docker ps-a. I have those two containers running. Notice this one right here is 1.0.1, this one's 1.0.0. So let's Docker stop 188. I'm going to Docker rm 188 as well, which removes the container. So now if I do Docker ps-a, I see just the newer version. Notice how easy it is to build up these containers and tear them back down. So we're doing a lot of up and down cleanup. I also want to show you something else. If you go to your little Docker container or Docker icon in your system tray and go to dashboard, let's pull that up. Notice that containers or apps, I have second container and it shows me that it's running. I can hit stop. I can go to the command line. I can open it in a browser. If I go to images, I can see what images are on my machine. I can even say run on these images, which may not be terribly helpful, but just know you can do it if you want to. And this one right here says in use. It's showing that I'm currently using this Docker image, which the important bit here is if you tried to delete this image, it wouldn't delete because it's currently running. Okay, it needs that image. Also note that 2 images on my machine, and yet the total size is 55.51 megabytes. Because even though each is 55.55 or 51 megabytes, we're not worrying about the duplication. Okay, we're not counting it as duplicate size because it's not storing it twice on my machine, just the once. So we are using just the space we absolutely need. We're using that layering technique to save or reuse those other layers. All right, so this Docker desktop can give you a GUI to work with. It's not nearly as powerful as the command line that I'm showing you, but just note that it is available to you should you want to play around with this or even just do a quick inspection. This is really helpful for if you forget Docker ps-a, you can just go to containers and see what's running, okay? And then you can stop it, you can restart it, you can delete it all right here. So let's do this. Let's stop it. And once it stops, notice it stopped. I can run it again, or I can then delete it. So yes, want to remove it. Now if we go to images, none of them are in use. All right, let's go back to our PowerShell. We'll clear the screen and do Docker images. Actually, let's do Docker ps-a just to show that yes, it did in fact clear that out fine. Now Docker images. These are all of our images installed on our machine. I can leave these here. Or what I can do is I can say Docker RMI for remove image. There's Docker RM for remove container, but RMI for image. And then I'll say, I want to get rid of 83B, 83B, which is Docker, Hello Docker 1.0.0. Cool, untagged it and deleted it. Now if I say Docker images, you see I had just the one image. I can get rid of that as well. Docker RMI 858, and it's gone. Now I have no images on my machine. Do you want to do that? Maybe, maybe not, okay? If you're trying to really hard to save space on your computer and you don't use those images anymore, cool, go ahead and get rid of them. Just note that if the image came from somewhere, you may have to re-download that. Now I want to show you one more feature of Docker before we start talking about why is this so beneficial for developers. So let's go back to the web and let's close out of these that are no longer running. And let's go back to the hub.docker.com. And in here, let's zoom out a little bit because it's a little excessive. In here, I want to search for RabbitMQ, which is actually, it's probably in this list in the first little bit because it's a pretty popular tool. There is HTTPD, by the way. Oh, I don't see it here. No problem. We'll do a search for it. I probably just missed it when I looked for it. But RabbitMQ. There we go. So 10 million plus downloads. So yeah, it's a pretty popular tool. And what this is a message queuing service. Now, I've shown you for Azure Service Bus and others as well, but that required Azure or it required installing something on your machine. But what if you want to test out RabbitMQ without installing it in Azure, but you also didn't want to install it locally? Because, man, that's a pain. Because now you have stuff installed on your machine, you may have some tweaks to it, maybe it runs on Linux and you have to install it on Windows and that doesn't quite work right, so you have to install it on a virtual machine and what a mess, right? Well, that's where Docker is just so powerful. If we want RabbitMQ, let's say I'm building a C# application that uses message queues and I want to test it out against a queuing service like RabbitMQ. Well, I can come to this Docker page for RabbitMQ. I can come down here and look at how to run RabbitMQ. Now, this command isn't the one I want because I do know that I want the management plugin as well, just to show you something, okay? And in fact, this one says you can access it by visiting this port in the browser if you run this command right here. Let's copy this. I'm gonna paste it in something that's a little bigger. And then from there, we can actually see what it does. So Docker run, that sound familiar? Yeah, it's gonna run an image, right? It's gonna run a image and create a container. That's what we did to run our image. Well, disconnected, yep, we saw it before. Host name is going to be my Rabbit. This is an additional thing that RabbitMQ needs to pass in. It's called an environmental variable that we're passing in to name our queue. The name of the container will be some rabbit. P for port. And let's shrink this down here. -P for ports, we're mapping on our side. Our side is going to be 8080. On the internal side, it's 15672. That's the internal port that their web server is running on. And this is a management server for RabbitMQ. But that's a hard port number to remember, and we can just map that to port 8080 or whatever port you want to on your machine. Then we say RabbitMQ : so that RabbitMQ is our image, which we don't have that image locally, right? No, we don't. No worries. But then : and here is the tag, 3-management. So this is, they name their tags really well. Most people do. So this is version 3 of RabbitMQ, and it is includes the management portion. Again, they try to create these images, it's images as small as possible. So if you don't need the management interface, then just do the : 3, which is version 3 without the management interface. But in our case, I want to show you something, show you actually working. So we want the management interface as well. So I just copied this command. I'm gonna hit enter. And it says, unable to find the image locally. You may panic. Don't panic. Because look, it's downloading it from the web. But notice it's not downloading one line. It's downloading multiple. Well, why is that? Because images are built layer by layer by layer, which means you can download these various layers. And if I already had a layer or 2 layers or 5 layers already on this machine, then it wouldn't have to re-download that. It would just download the layers I need. So now we've downloaded this whole thing, all right? And now it's running. So I can clear the screen, say Docker ps-a, and I have my running container. Let's go over to localhost, port 8080. There's RabbitMQ, which I believe the username is guest and the password is guest. Ever. Let's zoom out here because the zoom is too much for it. So this is RabbitMQ running. My message queuing system is already up and running. It's configured. I can start sending messages into queues. I can create channels and connections and exchanges and so on. Okay. All that's already set up. And that took me how long? If you pretend like you actually were going to find this and not just know where it is automatically, yeah, maybe we're talking a minute or 2 minutes. That was so easy. In a minute or 2 minutes to be able to find this command, get it running, and get it installed on my machine, and now I can start using it with C#. Simple. Okay, so this is one of the huge ways that Docker is so helpful for developers. Now, I've showed you how to create your own images, which are really helpful because if you decide to build out an ASP.NET Core web server, you can check the box when you start building to say, hey, enable Docker support. It'll create a Docker image based upon your web server. You can deploy that image. You can test it running the image, and you can have it on your machine as an image. But then you can also deploy that image and you know it's the same exact image and that image can be reused over and over and over again. It can be scaled out because if you need to create 5 instances, no big deal. You just point 5 different web servers to that image and you're good to go. Need 50? Cool, no problem. Just turn on 45 more. So that's really helpful. Then if you want to upgrade, all you have to do is say, okay, point to the new image instead and basically restart your web servers or web services. You're done. And you know that if it works on your machine, it will work in the cloud because it's going to be the same image. So what you have locally is the same as what you have in testing, is the same as you have in production. It will work the same way. Now, in theory, you'd point at a different database. So yes, there's different differences, but that's then down to the databases you're pointing at or the additional file storage or something else that you're pointing at. But the actual installation is the same. When you create that installation locally, that's the same installation you use across all different layers. But then if you want these different systems and services, and RabbitMQ is just one of them. I mean, if you look here, Postgres, Redis, I have a video on that, by the way. If you go onto my YouTube channel, I have a video on Redis that uses this Docker image because it's just so quick to use. MySQL, want to get that set up? No big deal. Just click on here and they'll take you through how to set it up and how to do the various things like username and password and all the rest. MongoDB. So for your NoSQL database, there you go. Or Node. MariaDB, which is a type of MySQL. Python, getting that set up. Oh, there's RabbitMQ. Golang. I mean, there's just so many different options in here where if you need something set up, you can do it in minutes and have it on your machine. But then even better. So I have this set up, I have it working, I can test against it, and then I say, you know what? I am done testing. I don't need it anymore. So I can say docker stop for C4. That's from right up here. Right there. That's the Docker container ID. That's going to stop the running container. Once I stop it, docker remove for C4. That removes it. Now docker ps-a, nothing there. I have cleaned up RabbitMQ. There's not files left behind. There's not folders left behind. There's not configuration changes left behind. There's not tweaks to my operating system left behind. It's all gone. Docker, let's do a clear first. Docker images. There's that RabbitMQ, which notice it's 187 megabytes. If I really want to, I could delete this image and then I'd save 187 megabytes on my computer. But if I might use it in the future, I'll leave it there. Because then the next time I want to create that RabbitMQ server, and I run the same command again, notice it was almost instantaneous. It's up. So if I go back to my web server and I hit refresh, there we go. It's up. So it's back up and running even after I deleted the container, I stopped the container and deleted it. So because it was on my machine, it didn't have to re-download anything. That's a real big help for your internet. I mean, the fact you're not re-downloading things. Plus, you can even do what's called a Docker pull command. So let's look at a different item. Let's go back to here and let's just say you want MySQL. There is right here this command, Docker pull MySQL. Let's copy that. Let's run that. I'll clear the screen first. Docker pull MySQL. And so use the latest default tag of latest. Okay, so I didn't say MySQL colon latest. I didn't say colon latest or colon something. It defaulted to the latest tag. All right, so there's a lot of different tags on here. If we go to tags, you'll see there's a latest tag, but there's also all these different tags, 8.0, 8.0.23, and so on. So if you want an older version of MySQL, say version 5.7, there you go, 5.7.29. You can scroll down here and go to page 5 and look for even older versions if you wanted to. So 5.5.43. But in our case, we're grabbing the latest version. And now, notice it didn't build anything. So if I do docker ps-a, I have just that one running for RabbitMQ, which we'll get rid of later. So Docker images, though, I have the MySQL image. And that's 546 megabytes. That's almost half a gigabyte, or it's over half a gigabyte. So that's a little more significant. But if I did this right now, where I have a connection to the internet, and then I jump on a plane, I can create containers from the MySQL container or image, and I can build those out. I can test things. I can use MySQL on a plane with no Wi-Fi connection. And then later, I don't have to download it again if I want it again later. I can just, again, create a new container based upon an image. Tomorrow, the next day, I can reuse this over and over and over again and never re-download that half a gigabyte. I've done it once. I don't have to do it again. So that's the very basics of Docker. There's a ton more to cover. And again, I have that course. I'll link it in the description. The Getting Started Docker course covers things like how do you map files in your computer, how do you use the run command, the different options for the build command, like how we set things up, other bonus commands, plus how to do other things like add HTTPS support for a .NET project, add unit testing into it, so that it's a whole like DevOps process where it tests, it builds the product, it runs the tests against it, it compiles it, it gets just the compiled code. There's a lot of stuff you can do here with this. I also want to show you, if we go to my YouTube channel, so https youtube.com/IAmTimCorey. I want to show you the search button right here. If I search for Docker, now this video is not on there yet because of the fact that I'm still making it. But this video right here, SQL Made Easy, SQL Development Made Easy with Docker, where what this does is I show you how to use Docker to take your production SQL server, clean it up, create from the backup, clean it up, test that backup by building a a Docker image of that SQL data, cleaning out all the personal information, and then giving the developers a development copy of a SQL database of the real production database, but cleaned up in about 5 minutes. Now, the video is longer than that. The video is an hour. But the process to run that takes about 5 minutes. So it installs SQL Server, it configures it, it takes our data and puts it in there, and then gives the developers a version of the SQL Server or SQL database that's practically the same as production, which is enormously helpful for testing your newest code. But also, it tests your backups. You don't have backups if you haven't tested them. So by doing this process, you give the developers the latest version of their production database to test against, but you also ensure that production database is restored and that restore works. So that's a really helpful one to learn. Also, Redis. Redis is a caching service for C#. Well, not just C#, but it makes caching data in C# really easy. Well, we use a Docker container to spool up a Redis instance. So again, really simple to do. We do something similar to what we do with the RabbitMQ server, but with Redis instead. So, and then down here, logging with Serialog, we set up a Seek server, which what that does is it captures our log information and creates graphs and other things. You can search through your logs and so on. Well, we use Docker to set up our Seek server so that we can have it up and running in just a few minutes. So why do I show you this? Well, because this is really important to know as a developer. Setting up Redis or setting up Seek or setting up a process to restore your SQL Server to a local machine and test it out, those things can take time. But with Docker, they can be very, very quick and automated. So setting up a RabbitMQ server can be very, very quick for testing. And then for testing your own applications, deploying them to a container that you know that if it works locally, will work on the server is a really big deal. So Docker is a huge tool. I definitely recommend you go to docker.com, get the Docker desktop, start playing around with it, start testing out these different images. Explore this list. Look through. I mean, there's 5.5 million images on the Docker Hub. Now, maybe you go to verified publishers, official images. I don't know. There's 591 of them. That kind of slims it down a little bit. But in this list, there's some great stuff. WordPress. Do you know how hard it is to install WordPress? Well, it's about 30 seconds worth of work if you use this Docker image. So really cool stuff there. Try it out. I encourage you to learn Docker. You don't have to be a Docker expert. You don't have to memorize all the commands. Write them down. But at least start to use it in your development process. Because if you're a developer, you should know Docker. It will make your life better. It will make you faster as a developer. It will allow you to test production level things on your machine. It will allow you to have a version of your production application locally in a way that replicates what it's like in production, so you can make sure that if it works locally, it'll work in the cloud or work wherever. But it allows you to do that in a way that is actually true. Right now, if you just build your code locally and it builds locally, we have that old joke, it works on my machine. And that's a very true joke because the fact that, you have so many settings and tweaks and other things that if it works on my machine, it might not work somewhere else because maybe they don't have the same settings and tweaks on their machine. And maybe the server doesn't. But if you use Docker, you know that it's going to be the same. So check it out, try it out, learn it. I love to hear what your thoughts are. I love to hear what your favorite Docker images are. If you use some of these images on this list, let me know. What are the ones that as a developer you find the most valuable? I may even do a video on my top 5 images. I love to have your thoughts on that as well. Leave those down in the comments below. I'll keep an eye on that, and and maybe I'll find something new and try it out. Maybe your favorite image will be in my top 5 or top 10 list of favorite images to use as a C# developer. Okay, thanks for watching. If you have any questions, leave them down below. I'll do my best to answer as many as I can. I can't get to all of them, but I'll do the best I can to get to as many as possible. Also, the code, what code there is, including the Docker file we created and the HTML files, will be in a zip file that I can email to you using the link in the description down below. There's also links down there to my course. There's links to the Docker Hub and to Docker itself, and so on. All right, thanks for watching, and as always, I am Tim Corey.